When you develop your app, everything is fine. Things are working perfectly. You have your perfect data set and you have your perfect way you're using it. But when people use it in real world, they put it under more stress because they use more data. And this can slow down your app quite a bit. And this kind of problems we want to actually address early on with writing our own tests in a consistent way so that I can automatically run these tests. In this tutorial, I'm going to talk about how to write automatic tests with XCTest. This can be used for unit tests, but also for UI tests. And I prepared some example screens that some of them work, some of them don't work so well. And on the left, I only put here like 100 entries in this list, so this is not a lot of data. When I am switching here between these tabs, I'm filtering these tasks by different categories. And as you see, once I tap on this, it updates really quickly and is very responsive. However, in this more extreme case of 1000 entries, you see there's a significant lag when this UI updates. And for my tests, I actually want to exactly know how fast this is updating. And also I want to write tests that measure, as you see here, these different data, these two different situations of a low data and a lot of data to handle. You can use the debug navigator to see the CPU usage and memory footprint. This would be a good indication, but as you see here, I would need to manually run this. So this is the bad implementation, which is using 135 megabyte, which is way too much for this little app. And also the CPU spikes are quite high with 50%. This implementation seems to be really bad behaving for large data, so it doesn't scale well. In this tutorial, I'm not only showing you how to do this stress test or this automatic testing, I'm also going through a couple of different implementations for lists. So how would I effectively do this kind of filtering here with lists, or lazy loading in this case, because I'm not lazy loading in this case, that's why it's behaving so badly. So we go through with VStack versus list, for example, what kind of filtering, if you use a computed property, or when should you filter, what implications does this have? And we also do a little example comparison to core data. You can find the link to this project files in the description box, so you can follow me along and we write our little tests. Let's now go through the project setup. In my project, I already added here the targets for the unit tests and the UI tests. In order to get good results for these performance tests, we need to run this on a real device. So I have connected my iPhone here. And in the UI tests, I am changed deployment info to iOS 17, or the one that for you works with your iPhone. And in the sign-in and capabilities, also for these UI tests, you need to add your developer account, otherwise you can't run it on device. And that was the whole point, to make reliable tests. If you want to add a UI testing target to an existing project, you can go in the target section on plus here and add a new UI testing bundle. I already added this when I created this project. So if you have a new project, like an app, you can here use this include test toggle to automatically add these test targets. Then I have one folder for my app files, the unit testing folder. This is also using XCTest, and this unit test would be something testing with my view models. Do I filter my data properly? Or for core data, maybe I want to test if I set up my NS predicates correctly, or my sort descriptors, or my fetches. Something like this would go in here. But the UI tests is, for example, one of the defaults they give you is measuring the app launch. So here you see measure with this measure blocks for the metrics of launch metrics. And then we can see how long the launch actually takes. In the other example file, they added here a XCT attachments. This, for example, helps you to create screenshots of your app that you can save. This would be, for example, very useful if you want to create a lot of screenshots for your app for the App Store. So you can automatically generate a whole set of all the screenshots that you need for different devices, for different languages. And it would run automatically, so you don't need to do anything manually. That's the other very useful case. Then let's create another file here to write our own. I am going to use a UI test case class. And I'm going to show you how to test the app flow. So if we press one of the buttons, we want to see another screen, for example. So this is the app flow tests. Probably would have specific test cases that you want to do. Now it already auto-fills some of the stuff here, and we are going to delete this and use the same style as already prepared. So this is in the setup function. This is called for the tests. We are setting continue after failure to false. That means if one of your tests fails, it stops instead of continuously doing this. And then we launch the application, and in the teardown, we just remove the application. So this block I'm going to use again in the other one. Now I can write a test. So this is a function. Test, you need to start this with the word test, otherwise it doesn't recognize it as one of your test functions. And I'm going to just test the navigation stack selection. Now in this test classes, you always have this little diamonds next to the class and also the functions. In the beginning you don't see this, so you just build and run this project. And then it recognizes that we have here a test function, because I named this here test. Then I go in here in this function with my cursor, and we are pressing here this little red button for record a UI test, because I want to interact with my UI, and it automatically generates the code that then later will help me automatically run this. So now we start again. I go with the cursor in this function and press here this record UI test button. Now the app launches, and when I interact with the UI, it will record the actions in code, so we can repeat the same actions as I did. So VStack. Okay, it lost the connection. Try again. Now it worked. You see it looked for UXC application. This is actually the app that I already have. I need to stop this here, pressing this button again. So app. In the app, look for collection views, and in there is some static text that is VStack with scroll view, and then tap on this text. So that's why I tapped here on the first one. In this case, I actually want to know that I'm really on this view. They are unique by this text here on the top. So I should have actually tapped on this one. So I delete this one and I record again. So I go on the first one. And then I tap on this text, and it looked in the app, in the navigation bar for this text. In this case, I actually tapped on it. That's why it has a double. But what I actually want to know is, or what I want to check is here, XCTest assert, expression and message. And what I want to have true is now that this text here exists. So it should find a navigation bar with this text, and I know I'm on the right screen. So I copy this and say exists. We are not on the VStack screen. The message that you can give here is if it fails this test. Okay, let's try running this test. Now I press on this record button again. It now automatically launches the app, presses this button, and then looks for this. And in this case, it succeeded. That's why I have here this green check mark, because the tests in this class are all green. I only have one here. The whole class is green. You also can see this in the navigator area, the overview of all the tests, what it fulfilled and what is all green. For example, if we change this now here and change the title, I run this again. It runs and it looks for this text again. But in this case, it didn't find it because I just changed it. So now here we have this failure with these red crosses indicating that something went wrong in comparison to the reference case. And so we now see we have a good case and a bad case, and we can test this flow in our app of user presses on this button should see the screen, user press, and then you can continuously write here more of these to say, if I press on the first screen, I should see certain things in the screen. If I press on this button, I should see a different one. Just going to go back to the good case that shouldn't work, and I run again. You can also run the whole class or all tests in this class. And we run, the app launches. It automatically presses this button. It looks on the screen, finds this text, and we succeed again. testing this app flows automatically, that the user can navigate from one screen to the next, maybe a sign-up flow or something. This is the probably most common case for UI tests. I'm going to do now these stress tests where I want to test how much load my app can actually handle, how much data it can actually handle. So first, let's create another file. This is again a UI test case class. And in this case, let's test the scrolling performance tests. I again going to remove these default stuff and take my setup and teardown functions. Okay, and then now I want to write now a function, so starting with test VStack. So this is the first screen, scrolling. This function can throw. And I know that I need to go on the same screen, so we're going to use the same tapping here. And you can actually do app.swipe up and swipe down gestures. So let's run this and see what it does. It automatically scrolls. I don't do anything. It waits until it idles and then it scrolls up again. Down here you see all the timestamp of what it did, of launching, finding certain elements. Now I want to actually measure what happens during this swipe interaction. Similar to the launch, you can also do a measure block around these actions. And in this case, I want to be also more specific and give the metrics that I want to measure. These are in XCTest signpost metrics dot scrolling and deceleration metrics. And the block I already have. Now it will measure the scrolling metrics, and I run this test again. These measure blocks will run 10 times to get some, per default 10 times, to get some idea of if it works well or not. So it scrolls down or scrolls up because I said so, and then down. It waits until it idles, so until no frames are updated. Scrolls down again, so it now repeats this 10 cycles. And you see here it does this swipe up and swipe down actions and measures the time in between for these to happen. This is, for example, interesting if you want to make sure that your scrolling is smooth and not interrupted or stuttering. In my case, it doesn't really make a big difference. It already works quite well. Once it's done, it gives me here no baseline, average for duration. The way these measure blocks work is you click here on these diamonds where you get the performance results. And here it's the average of 2.49. In this case, actually, it measured it 5 times. So you see here these variations of the measurements with a average value and the standard deviation, so how much fluctuations you have. In this case, it's 0.23%, so it's pretty much repetitive with 2.5 seconds. And the reason why it says here is no baseline is because if I set here set baseline, it now uses this baseline for our next measurements. And if we are, for our next measurements, not around this baseline with a deviation of 10%, so in this case it has to be between 2.25 seconds, 2.75 seconds to be still counted as past test. If you are too far away, if your next measurement is too far away from your baseline, then this test here will fail. We'll see some failed tests for measurements too. For my little example here, measuring the scroll performance is not really that great, or not so interesting, let's say. So we're going to create another test case, UI test case class. So this is a filtering lists tests. So these ones should end with tests. Okay, again, I remove the boilerplate code and I use here my setup and teardown functions. And now I wanted to write a function to test my VStack filtering. This can throw, we can have here a problem. So in this case, I again go to the same screen, so I can copy this. And I want to tap on a different button, which is here in this picker. The interaction I want to have is I want to first click on the VStack with scroll view and this collection view. And then I want to, up here in the picker, switch between the different filtering options. So in the app, it looks for a button with the name work. Tap on it and then look for personal. Now I want to actually see what the app does when I do these two interactions. So around these tab interactions, I add a measurement block. Okay, and now let's run this test. It goes on the screen and now it goes between these two tabs. This looked very fast. Now we can again use this diamond and check, oh, our average is 1.3 seconds. I can set this as my baseline. You can also have a look at the print area. So we see that we have an average of 1.3 seconds, standard deviation, and the single values are 1.3, 1.3. So it is pretty much consistent. And this is the time it needs to switch between this. It's mostly a UI update. And let's have a look at this view. In my filter stack view, I have here a list of 100 tasks. So I generate 100 random tasks. I use a select category that is connected to this picker up here on the top, and then I have a scroll view with VStack, and in the VStack I'm showing a for each with the filter tasks, and this is generated with the help of a computed property. So I go take the task and filter to see which task category is my selected category. So I update the for each every time when I change this category. Now in the current implementation I only test this for 100 tasks. If I now move this to 1000 and rerun the test again, it goes on the screen, it goes between these different tabs, and you see it already takes a lot longer. This is a clear indication that this implementation is probably not the best. It's also a question of, is the data that we're testing here relevant for our application, for use case? And if I have a task app, to-do app with 1000 entries, is this realistic? Would somebody be there and have 1000 entries? And I'm pretty sure there would be somebody. So being able to handle 1000 entries is kind of a requirement. Okay, now we have here a fail test telling me the time average is 400 times worse. So clearly away from the baseline. So my baseline was 1.3 seconds, now it's 6.7. So this is clearly not a good sign. I can also, instead of just what the time here gives me is the CPU time, you can also add here measurement object, other ones, because the one that I actually wanted to know is also the memory footprint. So this is I need to check what it is, XC CPU. This is actually the one we just had for this app, and then XC memory metrics for this app. Okay, let's try and run this again. You don't need to do this, you can just wait for mine. I will show you this in a minute. Okay, we are done. It's now green because I didn't actually set any baselines. I changed the measurements. And it gives me a few more things. And in this case, it gives me the memory in kilobytes. So this is quite a bit bigger than we wanted. This is also what you saw when I talked here in the initial tests. The memory footprint for this one is quite big. And I go here, and now you have a toggle to see all the different settings that are available. So this is the memory peak performance. The physical memory is 4.2 megabyte here around, and also I still have the CPU time. So this is the one we had before, 6.48 seconds. So you have more things that you can have a look at. So in this, for the implementation, where I have a VStack with a for each, this is using a lot of memory, as we just saw, and it makes our app also very slowly. Why is this? It's because everything is loaded at once initially when this view appears, everything. So SwiftUI needs to create here 1000 instances of this task row and directly load them into memory. That's why our memory is so high. Although we don't really need to, we don't see 1000 rows, we see maybe 15. Definitely way too much work upfront and memory usage. which we see in our implementation. As you see here, the VStack doesn't perform well with large datasets, whereas we're going to have a look at another implementation with a list. List is lazily loading, similar to lazy VStack, and it only loads the views that it needs to show on screen and maybe a little bit more. So for our app, only the first views that are shown, they are initially created, and when you scroll, it creates more. And it throws away the ones, or it actually reuses the one that leave the view and reuses them for the one that come in. So it tries to optimally use memory and CPU to not do more work than it has to and not to use more memory. Let's test this view that I can reach in my app flow. For example, here by pressing this filter inside button. So I use these. Okay, I copy this function because they are pretty much the same views, and instead I use now the tab on the filter inside list button. So this is list filtering inside, and see how this is in comparison. This is a lot faster, but I actually have a problem because in this first view, I changed the number of tasks to 1000, whereas in the second one, I still have 100. I don't really like this. Also, for making my tests more repetitive in the future, I want to actually run from inside this test case. I want to set how many elements I want to test. I want to pass in here the number of elements in this array that I want to test for. And for this, we're going to use launch arguments. When I create here my app, you can pass launch arguments. This is a array of strings. So for example, I can say -UI testing. Or if you want to pass a specific value, like in my case, I want to say exactly how many I want to have, you can use the launch environment where you can pass a dictionary of strings to strings, so strings keys. So in this case, I am saying I want to pass in one pair, where the first one is the key. So this is my stress test number, the number of elements in this array, and we want to pass in here 1000. Okay, so now I can pass it from the UI tests, and we now need to change our view implementation to a check for these launch arguments. When I go to my filter task list view, I have here this task generated random tests data that I used. This is because I have here a test project. Usually you would have this data coming from somewhere else. Like for example, in a view model, you would load it from disk, or you would have a fetch request to a server. So we are going to redo this and using this task view model here instead. So here in the initializer, right now I have here this demo of just generating me 100. So this is the task view model I want to actually use, which helps me better setting up my dummy data. This is more realistic for real app. So I go back and I use this. This is the task view model. And this is actually then, because it's the observer object, a state object. And now it's going to complain anything here. Yes, so because now the data is coming from the task view model's task property. So I'm going to do the same. I'm also using this task view model in the filter list inside. So I take these and replace it with these random ones. And then I need to here get the task from the task view model tasks. I do the same for the other two. The optimized list view already uses a different view model similar to this one. Okay, now I have this task view model that I can modify to take into consideration if you are launching from UI tests or maybe if it's a production app. So here in the init, I can do a conditional check which environment we are in. So in this case, I just want to grab my number. This is in the process info environment, and here I need to now pass in this key, which was the stress number. So we could say if I have a number in the environment, I know that I actually passed here from a test. So this would be this one case, else. And then if I get here this number, this is now a string. So I can create a number int by generating an integer from this number, from the string. As you see, this is a failable initializer because maybe the string that I pass here is actually not a number. Okay, now I have a number that I can use to generate me this number of random tasks. Okay, with this, I can, from my test here, pass in this launch argument, which I then get in the view model to use as the number of tasks. This will work quite well now, but I want to make this a little bit more convenient because I don't like to copy paste all the string values around. I'd rather have them in one place and maybe use them somewhere else too. So I also need to use them here in this view model. And I don't really want to copy paste this over there. So in the testing folder, I am creating another file, the Swift file. This is my UI testing helper. This is a struct UI testing helper. So we can generate static properties like if we're actually testing is UI testing bool. Similar to before, I can just use the process info arguments contains, and this is the UI testing key. And instead of here having this keys, I can also generate static var just is testing key where I store the string value, so I only need to here use them once and then I can put them everywhere. And then another key for the stress test number. Okay, now I need to just go and grab this that I then can use to extract the stress test number, which is an integer. Maybe if I didn't pass this here correctly. So this is actually what I already wrote here with this. So guard let else I return nil, and otherwise I have something and I return the number. I don't want to use the string value. I want to directly here use the property that I defined. This needs to be key. That was the whole point. And I declare the string values that I am here using to pass this around. I call them with key at the end and otherwise directly. So this is very convenient, and it's so convenient that I actually also want to use this for my tests. So if you go in the inspector, under target memberships, I also want to make sure this is be available in my UI test bundle. So I take this and now I can use this class in both of these. So that when I'm here in this class, I can reference this to say UI test helper dot is stress test key. You could also add functions to do this in there. But let's not overdo this. Is stress testing key, just so I don't need to copy paste string values around. Okay, now go back and in these view models. Okay, we have now set up this testing helper that we already used in UI tests, and I need to now use this wherever I am in my project. For example, here in this view model. So in this case, it's more simple. It's UI testing helpers stress test number. So this is the let number. Then I do this, otherwise I go back to this fallback. You can extend this more. For example, if you have a mock service installed, then you would use this conditional logic in there to check from what environment you're actually loading, or if it's a production environment. Okay, I do the same in my other view models. In the initializer, here I also do some filtering, and here's the same. Okay, so now I pass the stress test number from my UI test target to my main app, and I catch this in all the positions I want to, so that whenever for all of these views here, I use the number that I defined. So we're making this a lot more reusable and testable and future-proof, because in the future, even though if I change something in my project here, setting some different data, because of this, I can make sure I always use the correct ones here. And this is quite scalable because you can write tests for different numbers, for example. Okay, let's test this by only putting 10, because at 10 I will see. I run this test, going in the app, and you see I only have this few elements here because I said 10. 10 in total for all 3 categories. Okay, perfect. Then you can also test this for 1000 again. Maybe not for this function, for the other one, with the filter inside, because it's a little bit faster. And you see we have more elements again. Okay, I can stop. So we have now everything set in place to test the other implementations. And I have 3 implementations that I want to test against each other. So this was the VStack with scroll view. Then I have one implementation where I use a list where I pass all tasks, and inside this list I add here a filter. So this is not a good implementation because list wants to know all the elements in the list beforehand. If you do it conditionally here, it needs to do a lot more upfront. So this implementation definitely will see some performance drops. Then we have a filter where I use a computed property to filter this and then pass this. And I have an optimized list where I use a view model. So every time the selected category changes, I update the filtered tasks that are then shown in this list. This should not be actually a big difference between the computed property and this one. So let's test these. I already have one function to test the VStack, the bad one. The filter with list, this is the one I had here. And then I want to have the computed property, so I need 2 more. I'm just copying and pasting this because the views are pretty much the same. Usually you wouldn't do this, but this is filter list computed property, and then the where I have to tab on this. I have to tab on the filtering the computed property. And then the last is filtering list view model. We have to go on the screen with, we have to tap on the filter inside view model tab. Otherwise they are pretty much the same inside. Okay, I have now my 4 tests and they should work properly. I have made sure that all of them have the same situation of 1000 entries, and we can run all 4 tests by pressing here this button on the top next to the class. And these tests, to make them really reliable and informative, I'm going to run them on my iPhone, because now it's actually time to measure something properly. I'm going to choose my iPhone. I already connected this. Otherwise you can go here, manage run destinations, you plug in your iPhone and you give consents. Okay, so I now selected my iPhone, so that when I press here on this run, it actually should start it on my phone. Okay, you see now the screen of my iPhone, and I'm running here this test. It's going now through all of these tests. You can also check this on the navigator, which test is currently going on and which one it already did. This is now the very slow one with the scroll view on the VStack. Okay, now it finished. And we can have a look at the results. It gives me these warnings because I didn't set any baseline for any of these settings. So the one I cared about is the CPU time. So the first one is the 5.8 seconds that we already had, which is the worst one. So for future testing, let's just comment this one out. Clearly not a good idea to use that strategy. Then we have a look at filtering inside. CPU time is 0.4 seconds. This is good. I set this as baseline. And the absolute memory is 35,000 kilobytes. This is also quite high. We'll see if this is also scaling up. The next one was the computed property. The CPU time is 0.4 seconds. So it's similar. And the memory footprint is set as baseline. And then the last one. CPU time is 0.4 seconds, set as baseline. Memory physical is 42 kilobyte. Okay, I use the physical memory now as the baseline. And we are increasing our stress test number to 10,000 to see if this can still handle it. Again, this is a question of, should my app be able to handle 10,000 entries? And it might be a little bit extreme, but I think it should. Maybe you have a collaborative task app with multiple people working on it. It's actually quite a good idea to sometimes watch this to see the difference if you can spot it visually. We already have one failed one, which is computed property. So the CPU time is a little bit higher, so it's 0.1 seconds more. That's why I was also complaining. The other ones are also failed. Let's see which one is the better one. So the first one is, so I have here a CPU time of 0.5 seconds. So this is a little bit higher, but still similar to the computed property. The one that is really bad is actually the filtering inside. This is also true for the memory footprint. This is what I said, what we should see in the implementation. Where I use a list and pass all elements directly, the list takes this as, and then inside your usual conditional, the list has a problem because now it needs to, actually it wants to know how many elements are always in the list. And in order to do this, it actually needs to go through the whole list each time to check this condition, which means that this list has a lot more things to do every time I switch it between these different tabs. Definitely not a good implementation. The two winners that we now have is one time using this computed property, and the other one is with the view model. This is similar because every time I change the task model, I am also filtering this here and updating this property with the same algorithm, actually. So these two are the same so far. Where this strategy is actually beneficial is, in most cases, you would extend the functionality, but not only including here filtering, but also sorting. So I would be able to sort this by title, alphabetically, or by the date that they were created. And this view model here can handle the situation too quite effectively. So I have the filtered tasks, actually these are filtered and sorted. Every time I am changes the selected category, I filter, and every time I change the sorting, I sort them. When I filter, I not only filter, I also need to sort again. This is why I have here this function of sorting for different things. Maybe if the titles are the same, I'm also additionally sorting by creation date. This is quite effectively in sorting and filtering. As a little experiment, we are also going to compare this strategy with having this view model with this data with core data. So I have the exact same implementation here with core data. Core data is a very effective way of managing complex data sets, storing them on file and then also accessing them in your apps. I use the same properties. I just had to name them here different. So this is with CD task. So this is in the models, the basic task model as task, and then I have the CD task with similar properties. Also here with this object graph, I added quite a bit of helper syntactic sugar to make this a lot easier to read. Handling these optionals, working, storing here these enums, writing an initializer, adding here a function for fetching and the sort descriptors, and some example data. I do want to compare core data now to the other implementations, which means I also have to add here some default data. I also need to, when I launch this application for my test for core data, I need to also pass in here this 1,000 or this 10,000, however arrays I want to test this here with. And in order to do this, we are going to use the persistent file. When I launch my applications in the list performance project, I have create here an instance of this persistent controller shared instance. So this one goes through this init. And then here I have if I'm in memory, then I don't actually save this. So definitely I don't want to save this when I'm running here my tests. And I also want to add some dummy data to my view context with the number that I had. So here I say, oh, this should be temporary if I'm in memory, or if I am using here this UI testing style. So now it's in memory, and I also want to add some dummy tests, some dummy data. I already added here a function to add some data where I can pass this test number to in the view context. So here it creates this number of elements with this dummy data. So at the end of the initializer, I want to say, okay, if I am testing, and actually I here need to pass in this test number. So this should be if let test number is my UI testing helper stress test number. If I have something, then I can call this function, passing here this test number and the view context that I have here for my container. This is a static function, so I need to call persistent controllers add test data. I also use this test data function in my content view here for this dummy data button, because when you run your app, there will not be any data. So here I also use this to say whatever number you put in, add this as test data. So you can also use this yourself to see how it feels, if it feels interactive. Okay, so now I want to create a new test class so we can compare and see how core data is holding up. UI test case class, this is core data tests. I go in here and I copy again the setup and tear down. This is the same because I use the same strategy for my core data environments now. Before I can actually do that, I need to add. So which views do I want to compare? This is the filter inside the view model. Let's compare this one to this core data one. So I would need to press on the core data button. When I go on the filter lists, this is the same style here. I wanted to use this with this test list view model. And I need this twice, one time for core data. Test list core data. I already know that my filter list works for 10,000 entries. And we're going to simply start measuring. So now I run these tests on my iPhone. Visually, I would not see much of a difference. Both of these implementations are quite fast reacting. So let's just set a baseline for the CPU time. So half a second and 0.6 seconds. So both of them are okay. The physical memory is 32 kilobytes for core data and 65 for the other ones. Okay, and now let's do some heavier implementations of 50,000. This might be a little bit overdue. For core data, it starts to be a little bit slower than for the optimized list. So the CPU time for the array implementation is 1 second. And for core data is 1.5 seconds. So core data is slower and it feels slower. Now you could say, why would anybody still use core data? This is because I didn't actually take advantage fully of core data. Core data has a lot more tricks up its sleeves, and I'm going to use one of them now. When I am here creating my fetch request, right now the way I do this here, jump to definition, this is one of the functions I created. I don't specify how many entries I actually want to return here. So it fetches all of them, which means it's fetching all 10,000 or 30,000 in this. But instead of all, you can also specify in the fetch request the fetch limit to say, even though I have 50,000 entries in my database, but I don't need to show them. Most of the time, you're probably fine with just fetching 100 in the beginning. On my view, I can only show like 20 at a time in the beginning. So scrolling, you would need to go down quite a bit to even show 100. This seems to be a reasonable amount to fetch in the beginning. I go back to my core data test. So now, even though I have 50,000 entries, this screen will only load 100 in the beginning. Let's test this again. I'm just only running here this test. And my app becomes a lot more snappy and fast. If I now look at the CPU time. I'm actually below the one that I had before, so it's slightly below, but it's still around 0.5 seconds. This is pretty fast and faster than this list implementation. This one scales nicely because no matter how much I have in the database, I don't fetch everything. Now you could say, if I'm here in my list and I only fetch 100 at a time, what happens when I reach the end of this list? I mean, in some cases, there might be people who want to get at the end of this list. You can not change these property. For example, I would also use here an on change. Maybe I have a property that checks how much I go. I cannot update this if you go in so here, for example, I can change the task and its predicate to update for this category. That I can do, but I cannot change the task's fetch limit. I don't have access to this. I can also not change something else that you can use. Paging is, for example, the offset. So then you can say, change this fetch request to get the next page or the next. So I'm offsetting by another 100 and then I'm fetching more and more. So this would be helpful for something like paging. So how do I get around of still fetching here more? So instead of using this on change modifiers, which you can use for filtering, you can also use it in the other implementation here for the sorting. If in onChange to change the NS sort descriptor. The older implementation is if I use a subview and in the initializer I pass in the category and the sorting, and here I create this fetch request and set it to my underscore tasks so that here I can change the request's fetch limit to a fetch limit that I am actually passing here to this fetch limit. Now I need to pass this here. And one thing that I actually want to change is that I need to track if I reach the end of this list. And I need to add one more element. I need to do this in the list outside. So I am changing here to a for each. The selection moves up one level together with the selected task. So now I create here a state property for fetch limit, integer of 100. I use a list with a selection to my selected task. Inside here I can use this, which is actually not a list, it's a for each. So this is a fetch limit where I pass this fetch limit. And then I add at the end a placeholder. You could probably also use some different logic. Frame height of 10. So that when this one appears, I know I'm at the end of the list. And I can increase my fetch limit by, let's say, another 100. For this test, let's go for 10. So now I'm actually not getting so many because my preview is set up differently. I jump to definition, to the preview one. You see the test number is 550, so I increase this to 1000, so we have more entries. So initially I have 1000 entries, but I only fetch 10. It does already fetch more because it's already appeared. You see that the scroll bar shows how large this list is. When I scroll, you see it jumps a little bit. This is because I'm continuously adding more elements. I don't really care about the scroll indicator. For the smoothness, the list still is smooth. You see it just continuously goes more. You could optimize this by fetching this in batches or something. This was just one idea of how you can optimize this list even further with core data to not do too much work initially. If you want, you can also add tests for this kind of implementation. I didn't add it to my main content view yet, that's why I can't connect it, but you can test this and just see which implementations you want to have. So as you see, having core data as your database, if it's very complex, it's quite beneficial for this kind of filtering or sorting, only fetching the data that you need, so quite good for performance optimization. Once you know what you're doing and these little tricks, handling the data and everything, Usually people complain about core data because it's difficult to get into. I have a dedicated course about core data that teaches you quite a lot of these, so you can really take advantage of it and properly use it. I'm going to link this in the description box. I highly recommend core data when you have large data sets that are complex with relationships. You want to do a lot of filtering, advanced filtering, maybe filtering for multiple things, like not just by the category filtering, but also by timestamps, certain time periods, or for the tasks that are already done. So you can really do some advanced stuff with this. Much easier than doing some array filtering and managing the data yourself. There's also Swift Data. This is the newer storage solution from Apple, but it's not mature enough. There's a lot of bugs and limitations. Usually I hit a roadblock every 5 minutes or something is not working, especially filtering with the new predicate macro. Relationships and optionals, it's a drag. I really recommend staying with core data if you have something complex, because it will save you a lot of headaches in the long run. A little bit more difficult to get up and running, but it scales nice and there's already enough resources to do stuff with it. Okay, just as a little summary of what we did, what I showed you is sometimes you have a lot of things people tell you how to do it in SwiftUI, which implementation is better. For example, you were not sure what it means to use VStack or this lazy loading. Is it really something that is necessary for your situations? And now you have the tools to test this yourself by writing UI tests where you can define the test environment. For example, what data you want to test. This should also be repeatable. Right now I use random stuff. That is also a little bit limited for making this a reliable test, but for our case with this performance, it's pretty good. You can decide how much data you want to test your app with to really do a stress test to see can it actually do the amount of data of work it's supposed to do for more advanced things, not just your little tests on the device with very basic things and little small images and perfect images that are small enough to handle, for example, but really here some heavy lifting to test different environments or different implementations, as you saw here, to see is it really necessary to do this advanced filtering, or that you shouldn't do filters and lists, for example. But you can also use these tests for continuous development of your apps. You set up one test once with a certain baseline that you set here. In the future, you might do some changes. Maybe suddenly your app updates too many times, and one of these tests will actually, hopefully, fail, so you know when something is off again, so you can investigate again. It's a little bit of a security for this performance, but also the use case that is probably more widespread is for testing this app flows, where I tap one button and then I want to make sure that another screen comes up or certain things hide or show. I didn't also go into making this a little bit more working in the long run. For example, with accessibility modifiers, with accessibility settings, instead of here my names on these buttons, you can also use the accessibility identifiers to make sure you're always pressing the right one. For example, maybe in the future you're changing this title to something else. So it's not really a stable way of making sure it's always the same. Whereas if you're using these accessibility identifiers, you're probably not going to change them in the future. So a little bit more future-proof if you want to use them for your tests. I hope this gives you a good idea of what UI tests you can do, when you should do them, and how they can help you in making your own apps. If you like this video, don't forget to like and subscribe. Until next time, happy coding.